So it was the same equation. Was it a rock again? Oh, an object. Okay. Force 4, same thing, just 4 seconds. So how do you find the average speed?
Plug in 4 for t. Divide
It's
by
just distance divided by time. So you figure out in 4 seconds how far, well, so your 4 is going to be on bottom. And you figure out how far did it fall in 4 seconds.
4 times.
So it's 16 times 4 squared. Because that's your position function.
Yeah.
16 times 16, you get 256. What is this? Feet?
Divided by 4.
What are we in here?
8.
Feet? In 4 seconds, divide by 4.
64.
64 feet per second.
That's because I was looking at my notes and we had a three.
Number 4 was instantaneous velocity. Find the speed at 4 seconds and confirm your answer algebraically. There's 2 ways of doing this, but you only know one so far. So what did you do? Who did it?
I put it in an F.
Did you do this? X plus H minus, oops, T.
T.
Probably T right here.
Yeah.
It's time. Whatever.
F of t.
Yeah.
That?
Yes.
Okay, what'd you use for H?
I put 4.000001.
Yeah, that's what I put.
So you used 0.0. So
Five
you
zero.
all just took something and plugged it in for H like 0.0001, right? That'll work.
Anything in? I put 4
I don't think I did it right though.
You could, but you're going to be most accurate the smaller it is.
You put
The
4.
smaller your elapsed time is, the more
You put
accurate
4
you'll be.
No, I didn't do it.
Oh.
It's confusing.
So if you did like f of 4 plus, I'll just do 0.0. How many zeros?
I put 4.
4 zeros?
Yeah.
Wow.
I put 5 zeros.
Minus f of
You
4
say you wanted to get super close.
over 0.000.
0.
1. And so you plugged in 4.00001, and then you plugged in 4, and you subtracted those, and you divided by. That sucks, huh?
Yeah, it was 256.001.
How do you put it?
Remember what this means? F
Yeah.
of
You
something.
gotta plug it in.
Plug it into T.
Oh, I did it.
Which is the same as the first one because it's just 0.01
I got
more.
128.
That is correct.
That's why I got
Oh, there's a 240.
Should
No, I was saying the steps of
Oh.
You should get really close to 128. There's a better way to do this. Should we do it right now?
No.
Yeah,
Yes.
we'll come back to it. Let's do the next couple. 7 and 11 were the same thing.
Do you not plug in
Excuse me.
hat or X?
You're on 7 already?
Yeah.
Yeah, that's what you do. Negative 1/2. The
Because-
limit as x
Yeah,
approaches
zero two.
negative
You
1/2,
can't multiply by 0.
3x squared
Good job.
times 2x minus 1. Yeah, as x approaches negative, sometimes the limits, the easiest way to do them is just to plug that number in.
Can you
That will change today, but for right now, you just plug it in and you go 3 times negative 1/2 squared times 2 times negative 1/2 minus 1. It's not 0.
Oh, I
It's
didn't get
negative
negative
1/2.
1/2.
That changes it.
Uh-oh.
2 times negative 1, well, I'll cover negative 1/2 squared is a fourth.
So you have negative 1/8.
3 times positive 1/4. And 2 times the negative 1/2 is negative 1 minus 1.
Because it's negative 1/2.
That was the problem.
We thought it was 1 minus 1 is 0. We all did the same.
They have a really small font.
So we got 3/4 times negative 2, which is negative 6/4, which is negative 3/2.
But if it was positive half, it would be 0.
If it was positive half, it would be 0, yeah. That is true. I think the next one is 0.
Yeah. I had negative 0.30.
Wait, negative 3.
answer graphically.
Which one's out first?
We didn't get to talk about graphs this year. I don't have graphs.
Wait, number 11 is 0?
Yeah,
Why didn't we get 0?
because negative 3 squared is 12 plus 9 plus 4 times negative 3 is 12 plus 3, and then add all that together, you get 0 over.
So what this looks like on a graph,
Is it a subtraction? Oh, is it minus 12? So 12, but, oh, duh.
you graph the function.
Let's see.
Oh, my window's all weird. I'll just go standard. Okay. What this says is find the value of the function as x gets really, really close to negative 1/2.
Let's see.
So on the graph, negative 1/2 is like in here. I could change my window to make it look better. I'll just look between negative 1 and 0.
I was like, what's over?
There's just some up something not having class.
See, I would stop right there because I was
I zoomed in. Here's negative 1/2. Here's the graph. So I look when x gets really close to negative 1/2, what's the value of y? Well, you can kind of trace, oh look, if I just do it. This one, if you just look, when x is negative 1/2, y is negative 1.5. Isn't that all we got? Or if you look on the table, you can look on the table also. As x
still
gets,
number 7.
yeah. As I get to negative 1/2, y is negative 1.5. 11. Just plug it in. You get 0. Everyone get 0.
I got negative 0.33.
Uh-oh. So it's just negative 3 squared.
Ah, I copied it wrong again.
I know, I didn't put a negative either.
Ah, it's a good time.
Right? You're just plugging in the negative 3. You should get 0 as your answer.
I do the same thing. The arrow and the negative look like they go together.
19.
Little arrow.
19, you were supposed to fill in those tables. Like you were supposed to do all of them and plug them in.
Oh, I did.
Anyone know?
And so that just sucks. I mean, nobody wants to do that.
I did it.
You did it?
Yeah.
You just plug them in for X or what?
Yeah.
I did it
So you
right,
just,
but-
you fill in the tables. So negative 0.1, and you plug it in for x, and you get an answer. And then you do negative 0.01, and then you do negative 0.001, and then you do.
Yeah. I actually
Thank-
got it.
Actually, I didn't even
You want the answers, Alondra?
Yes, please. You can just do one.
I'm gonna do this for next.
There. So you get 2.06, 2.28, 2.299. Then if you do this one, you get 2.305. So the answer is 2.3.
You're getting like 10 something.
What? 10?
Yeah. 10.7.
You go 10. 10 to the power of. Wait, what? Where is it? It's right there. 10 to the power of. If you're doing the first one, you do parentheses negative 0.1 minus 1.
Divided by.
Then you. Oh, okay. There's your problem.
You gotta equal it first.
You have to put parentheses around the top. Otherwise, the calculator,
This is why I stopped doing it overnight.
it'll do 1 divided by. It's gonna do that
Can't you
first.
just find the answer
And
then?
Yeah, and then
subtract
divide
it
by
from
1.
10.
Can you put enter and then divide by?
Yeah, you could just put enter and then divide by negative
Negative
0.1. Or just put parentheses around the top so that the calculator does the top first and then divides by x. That's good. That's good learning. Okay, there's those. I told you there's another way to do number 4, a better way. Let's talk about that. Number 4 was the instantaneous velocity. I didn't actually say that. It just said find the velocity of the object at t equals 4. So a lot of you used f of t plus h minus f of t divided by h, right?
Yeah.
There's a way to do it sometimes. without plugging anything in for it? Well, we want h to be 0 ideally, right? And I know that f of t equals 16t squared.
Divide by,
So what I'm going to do is I'm going to work this out. Oh, and t is 4, right?
Yeah.
So I'm going to go f of 4 plus h minus f of 4 divided by h, and leave the h's in there and see what happens. I mean, some magic will occur. So f of 4 plus h, what do I do with that? What's that mean? What do I do with it?
4 plus h and
Yeah, you plug 4 plus h into t up here, right? So I'm going to go 16 times 4 plus h squared. I'll leave it for now. That's just this piece. Remember last year people got confused about this, so I went slow. See what I did?
four.
Just plug 4 plus h in for t. There it is. Now I'm going to plug 4 in for t. So 16 times 4 squared. And I'm going to leave the h. Remember, I want h to be 0, right? To get my most accurate answer possible.
Correct.
Right now, h can't be 0 because I'm dividing by h. But, let's simplify the top. 4 plus h squared, what is that?
16 plus h squared. No, oh, it's that one thing, distributive property.
It's not 16 plus h. It's 4 plus h times 4 plus h.
So 16 plus 8h squared plus h squared.
Yes, distributive property, you got 16 plus 4h plus 4h, so plus 8h plus h squared. All of that, so I'll do it one step at a time here. So we have 16 times all of that, 16 plus 8h plus h squared, minus, so that is 256 over h. Well, I can do distributive property here, right? Am I going too fast?
No, you're fine.
See lots of pencils.
You're good as of right now.
Distributive 16 times 16, do you know it yet?
256.
256. 16 times 8h,
128.
28h. And then 16 times h squared is 16h squared minus
You have to
256
factor that?
over h. No, you don't, because look at, we have a positive 256 and a negative 256.
Oh, look at that.
Bye-bye. You see anything here?
You can cross out an h.
Don't they all have an h?
Yeah.
So 128
So
plus
if we
16h.
factored out an h on top, we'd have 128 plus 16h over h. Boom, boom. Now we have 128 plus 16h. Hey, didn't we want h to be equal to 0?
Yes.
Yeah.
and
Can I
that
make
can
h
be-
0 now?
Yeah.
Yeah. So if h is 0, there's my answer.
That was cool.
What?
Do we always want h equal to 0?
Yes.
When you're doing instantaneous velocity, yeah, because h is our elapsed time. We want our elapsed time to be nothing.
So now we could do elapsed time without having to do the other stupid way.
Plug it in a whole bunch of crap and
Honestly, this way takes longer, but
it takes a
It's
little
more
longer,
efficient.
but
You can do the exact
you're going to have to do it more in the next few sections. So. In fact, I should give you another one tonight.
Well, if you start really small, it takes forever, but
Just added one. Man, you're going to have a good weekend. All together now. So that's that. Let's see.
I don't care as long as I can do it.
Going back to limits. We're going to talk about how to evaluate them more and show you what You know how number 7 and 11, you just plugged in the number and you got an answer? That doesn't always work.
Math camp.
So,
Stupid math.
for example, if you have something like this,
Imagine if it went to math camp.
That was gonna be
Like,
fun.
through the summer.
can you plug it in?
No, she can't go on the bottom.
This is a crappy example.
You always do that.
I know, I always have horrible examples that I pick. Let me see if I can find a better one.
I don't think you can.
Oh, really, Eddie?
No.
What?
Looks like I keep running.
She didn't think you have to record.
No, she kept asking us to.
Oh, that's not a very good one.
No, I wrote it down. I know, I was like, no, they didn't ask for us.
No, I told him. No, I was like, do we have bacon I could take? He's like, yeah.
Okay, so if you do this, if you plug in 0, what do you get?
And no solution.
Nothing, you can't do it. But it might have a limit still.
What exactly is
Yeah, yeah.
That's the value that this gets, that this goes to as x approaches 0. So as x gets really, really close to 0, what does this get really, really close to? So we can look at the graphs. Do you know what that graph would look like? Anyone?
Yes, it would be a.
that the thing right here?
This?
The,
This.
yes, the split.
It's x squared though.
Oh, I don't know.
Is it square parabola?
1 over, don't pay attention to the top one. It's
It'd be,
not,
it'd
it's
be
not
a
gonna graph.
downward parabola.
So 1 over x squared, if I graph it, it looks kind of
Oh,
like
never mind.
the other one. But in this case, there's nothing at 0. If I go, what is that? What do I get close to? If I move like this, it goes up. If I move like this, it goes up. So the limit, this one doesn't have a limit. That's why I said it was a bad example. The limit does not exist. Now you know what that means. Sometimes
Wait, that's not a movie. Mean Girls.
Yeah, look,
things don't have
Oh, yes,
limits.
when she's like replaying her.
The limit doesn't exist. Yeah, she got it right. Good job.
So we don't know how to do that one quite yet, but
That's funny.
at least now you know what she means when she says that. So if you have that one,
I don't know in life.
he looked like straight at me.
this
It's not existent.
this is a better example. If I just plug in 0 for x, can I do it?
No, she can't make some of
No, because you can have x on the bottom. But guess what? This one does have a limit. And if I look at the graph of it, I can see it. Let's get rid of that. So I've got it already typed in here. If I graph it, here we go. What's happening? When x is getting close to 0, what is this getting close to? Well, it's 1, 2, 3, 4, 5, 6, 7, 8.
How did you plug that into your
You have to put parentheses around the top.
4 plus x?
You have to put,
Parentheses.
you have to put parentheses, 4 plus x, parentheses squared, minus 16, close the,
Oh, I didn't even divide it.
divide by x. So on the graph you can kind of see it. On my table you can really see it. Look, as x gets really close to 0, as I go down, look at 7.5, 6, 7, 8, 7.9, nothing, because I can't divide by 0. And then it keeps going on up. So what do you think the
8.
limit is? The limit is 8. Yeah, this one does exist. So sometimes graphically is the way to go.
Can you always put it into that part?
Unless it's a gray circle problem.
Oh, because it's in between us.
Unless it's a what?
Gray circle problem and you can't use a calculator. These are all graphing calculator problems.
So like on the test, would you give us that on a non-calculated problem? Test portion?
You're going to learn how to do them all without calculators. But not today.
Problem portion.
So just looking at graphs with limits. If you look at the graph of f of x equals x squared minus 1 divided by x minus 1. The graph of that looks like this. Okay, so if I said find the limit as x approaches 1 of this function. Here's another example where substitution, if I just plug in 1 to this function, does it work? No, because you're dividing by 0. But looking at this graph, as x gets really, really close to 1, what does y get close to?
2.
2. So the limit is 2. Even though there's a hole there.
Can you repeat that again?
As x gets close, this means as x approaches 1. So as we get close to 1, from either way, the value of y goes right to 2.
They're always gonna work like that.
You could have something like this, too. Here's another function that almost looks the exact same. Piecewise, remember piecewise functions?
Yep.
Those are my favorite.
I hate, those are like the ones I did not understand. the most.
So it's the same function, but now only there, but we're going to add a piece. So it's almost, I'm just going to use the same picture, okay? So I don't want to redraw it. Are you guys trying to draw this?
I already did draw it.
There's a picture in your book if you just want to look
Oh my goodness.
I
you're
don't
always
have one
reading
of
too.
those.
Still? So this
Yeah.
is the same thing, except when x is 1, g of x will equal 1. So there's a dot down here now. It's just a discontinuous function. So you've got this line, and then there's a hole here, and there's a dot down there, and then the line continues.
That's freaking weird.
That's just dumb.
It's a piecewise. You can do that.
That's
You're going to see
retarded.
lots of crazy stuff. So it's like a hole, and there are dots down there. What do you think the limit as x approaches 1 of this function is?
1. I'm wrong, just kidding.
As you get close to 1 from either side, what does the value of y get close to?
1.
2.
Doesn't. It gets close to 2.
But when
Just
it equals
because
1, it's
g
1.
of 1 is equal to 1, it doesn't mean that the limit as x approaches 1 is 1. It's getting really close to 2. When it does hit 1, there, yeah, it's 1. G of 1 does equal 1, but the limit as x gets close to 1 is still 2. Because you're still getting close to 2.
So if you have two different functions on one graph that have the same limit,
This isn't two different functions.
totally just lost me there. I was understanding until that.
The limit of this one, this graph right here,
Yes.
is still
It's
2.
2.
The limit as x approaches 1 is still
I
2.
get that
Even
too.
though there's that dot down there.
It can equal 2.
Sure. Like, so if you put in something else except that dot, is what I'm asking. Like, let's say instead of the dot, it was another line. Is it the same thing?
Another line. What do you mean, another line? Just hold on. I think this will make more sense in a little bit. Because we're going to do lots of those,
Tell me.
where it's weird. In fact, I don't even know if I should do this one next. Yeah, let's do it. Do this one on your graphic calculator. The limit is t approaches 2, t squared minus 3t plus 2 divided by t squared minus 1. Can you plug it in?
What can you plug in?
No, can you just use substitution and plug 2 in for
No,
t?
she can't zero the
No, you're going to get 0 on the bottom. Well, let's use our graphic calculator and see if there is a limit. Remember to put parentheses around the top.
Can I just put X?
Yeah, your variable on your calculator is x. It doesn't matter what I write here.
Can I just put double parentheses?
No.
That's only if there's already.
Put them around the top and the bottom.
Use X.
Oh.
What you got?
Yeah.
Everyone graph it right? So what's the limit?
between 0 and 0.4.
Start the parentheses.
My calculator.
It's in between 0
Huh?
and 0.4.
Error? Push zoom 6.
What did you say?
Does it now look right?
Yeah.
You talk about it? Yes.
Oh, why does my calculator do that? I did it last time during.
It's between 0 and 0.4.
Oh yeah, some of them, that is like trying to show.
Last time I did that in the beginning of the year and it kept doing that. I didn't know why.
It's trying to show you asymptotes. Well, and you put x squared minus 6, so 4. Oh, this one goes fast. It's like, yeah, you want a different calculator?
Sure.
So to find so you go into the table and look when x equals 0.
Oh, go into the table, that's good.
Mine is like 1900.
And look when what?
What do you, like, what
When it
point do you
says
look
error.
for?
I don't know, what's it asking for?
When it's approaching 2.
And then when it's at 2, it says
And x is
error.
approaching 2.
So it's between 0 and
So you
0.4.
might have to change your table.
No, it's good.
Scroll
Uh,
down.
it says error twice.
One of the most
At
here.
-2?
-2 dash
She's
0.
like, because she thought she was one of the students. She's like, no, I'm like 25. And he said,
Okay.
Thanks.
If you don't know how to change your table, it's right above window.
Wait, why would you want to change it?
Well, because watch, I go to my table.
And it says error at 2.
Mine's actually pretty good, but some people's were like,
1, 2, 3, 4, and it's error at 2 and -2.
they're like this, and they're like, holy crap, I don't want to scroll all the way back to 2, because look at it, I mean, that's going to take forever. So you push table second, table set. I want to see when x approaches 2. So I'll start at, I don't know, 1. And I'll let it, and this is changed in table, so this is what it's going to go by. Do I want it to go by 0.1, 1s, 5s, 1000s? I'll go by 0.1s. I mean, it's not bad. So now it's going to go by 0.1s. At 2, I hit error. But what do you think? What's going to be the limit?
2.
We can make it. It's kind of hard to tell right here. It goes from 0.23 to error to 0.26.
Mine says -2 is error 2.
0.25,
Yeah.
2.
Yeah.
And it says 0.4 error.
How'd you get it to
0.
do that?
Table set.
Table set.
I'll start at 1.9 and go by 0.01s.
0.01. Crap.
Yeah.
Table.
This. Now is it becoming a little more clear what the limit is?
But
Wait,
why
mine
are
says-
mine and yours different?
Mine says -299.
About
Oh wait, I'm in the
0.25.
wrong spot. Never mind.
Yeah, you want x to get to 2, not -2.
Did I grab that one?
You need to change your table. You're going by ones on the x.
Squared
The
plus
second, table set.
plus
Start at 1.9.
2
And have the change go like 0.01. And go back to the table. Go back to the table.
-0.9.
No, positive. We're looking when x is positive 2. When x gets really close to
Start at
positive 2.
1.9.
So I'd start at 1.9 and go by 0.01s.
when X gets what?
It's like a 2.5.
My calculator.
When X gets really close to 1, it says what?
0.25.
It doesn't
Oh,
work.
you didn't parentheses.
2.25.
So it's just going to divide by x. It's going to take that and divide by x.
Because on 2 it says error. So we're trying
Not on here.
It's all about parentheses. That'd be a good song.
It's all about parentheses.
I just thought of an old song called "It's All About the Benjamins." Peggy. You heard that?
You gonna sing it for us?
Puff Daddy. You change it. It's all about parentheses. That's hilarious if you know the song. Okay.
So it's between 2.248 and 0.251.
Yeah. So what's a good guess for that?
0.2.
0.25 probably.
0.25, yeah.
1/4. I think that's a good answer.
So like when you put the answers, like let's say someone says if it's 0.24, it's not gonna work. So 0.2.
No. Check this out. We did this graphically, right? Watch this. This is gonna blow your mind. You ready? Factor the top and factor the bottom.
Good, it's 2 squares on the bottom.
Difference of 2 squares on the bottom. What's top? I'm using x's now, t's, whatever.
After that, just kidding.
Can you even factor it?
Yes.
Minus 2 minus 2.
Minus 2 minus 1.
Yep. What happens?
You can
X
get rid of
minus
the 2.
2's are gone. I have x minus 1 over x plus 2. Now can I plug in 2?
Yeah.
And what do I get?
Why did you tell us that before?
Because I'm having fun here.
You have 1/2.
So we did it graphically and algebraically and we got the same thing. Even though we couldn't plug 2 in right off the bat,
So should you try that every time? So you factor it first and see.
I do graphically first just because it's easier.
That's not easy.
That's not easier. This part was way easier. It's easier to put in the calculator now. Okay,
Yeah.
that's true.
As long as you know how to run your calculator. One more thing.
I will learn how to.
I learned a long time ago because I figured out it was easier.
One-sided limits. So right now, for up until now, all we've been doing is two-sided limits. Now we're gonna have one-sided limits.
It sounds easier, isn't it?
It is, I think it is. The way that's written is like this.
Sorry.
Well, I haven't written the whole thing. You know how to read that? Somebody read that. The limit.
X is getting closest to C, F of X equals.
Okay, we'll go the limit of f as x approaches c, right?
I'm literally.
Well, now we're gonna add one little piece. If there's a little plus sign right here, like an exponent above the c, that means from the right.
You said good.
He said good.
And we could also write the
Wait,
limit
what's that first
C to
letter?
the T?
F of X
c
y?
to the plus sign.
I said plus sign?
Yeah.
So if it's
And we could have c to the negative sign, and that's the same thing. Blah,
Okay,
blah,
what is
blah.
that, what is that
That's
letter right
from the
there?
left.
Or what is that? Before the?
It's an
It's an arrow.
Oh, that is this.
Just showing you how to read it. So this is from the left. We'll do an example here. Time to do everything I want to. So I'll skip that one. So we're going to find some one-sided limits here. I'm not going to write the function for this. It's just a piecewise function. So there's our function. It's a piecewise function. We could write the equation for it, but it's in your book if you want to see it. I don't think anyone cares. So we're going to find limits for this, like the limit as x approaches, and we'll call this will be f of x. The limit as x approaches 0 from the right of f of x. That's an easy one. So literally all you do is you start from the right and you go towards 0, and what am I getting close to?
1.
One. You start from the right and go to the left?
Yeah.
Okay.
It's from the right, from the left. So you may think, well, that's easy, but then sometimes you can get different answers. Try these three. Try the limit as x approaches 1 from the left. The limit as x approaches 1 from the right. you'll get 3 different answers for those. Just take a couple minutes and think.
How would you go
Just
about
take a
the
couple
last one?
minutes, take a minute and think.
Is it all be on that same line, or it could just be within the whole graph? Like you can use any pieces.
Yeah, the whole function is, you can use any part of that function.
Don't worry.
He's really
He just likes making us look confused.
Your 1 minute of thought is up.
just
Okay.
I don't know what I'm doing.
The limit as x approaches 1 from the left. So all you're saying is in this function, as I get close to 1 coming from the left, what is my value y getting close to? 0.
I thought it was this. Oh, okay.
Don't do the next one really quick.
Even though f of 1 is 1, kind of like that other one, even though if I'm at 1, the value of y is 1, that doesn't matter. It's as I get close to 1 from the left. Okay? What's the limit as x approaches 1 from the right?
What is
Wine.
It's 1. Because here's 1, as I get close to 1 from the right, I'm getting close to, it's getting close to 1, right? So I'm getting different answers whether I come from the left or come from the right.
That really is.
This is the two-sided one. This is from both sides.
1 and 0.
If you get a different answer, it doesn't exist. There's no
If
answer.
you get a different answer from the top.
Meaning,
Like if
if
you
you
get
come
two
from the left and you come from the right,
They're not the
and they
same.
approach different
Like
things,
those.
the two-sided one has no answer. There's
So
no.
one's an open circle, one's a closed circle? Is that what we're getting at? Or no?
This limit doesn't exist right here. Because if I come from the left and I come from the right, I get different answers. The limit as x approaches 1 from the left is 0, from the right is 1.
Almost lost to
But if it were
like
both
they
one,
always both games.
Yeah, if they were both one.
Really?
They're not that good. We watched them. Me and Larissa went.
Do you want one more example real quick? You're going to miss 1 minute of lunch. Are you ready for the homework?
Give us the homework.
Let's just do it, a lot of this from the left, from the right. And if there is no plus or minus sign, that's from both sides. And there's some stuff like from yesterday. And there's a lot going on here.
I'm so excited.
That's good, Isabel, you should be.
Too bad she couldn't.
Dang.
What?
You know,
No,
on
fine,
the
everything
boys,
is
how they
fine.
have the practice test right here.
I'm gonna get complicated unless I
Why
write
does
43. There's
it
an
say
A,
on?
B, and then a
Yeah,
C,
there's
D.
A, B, C.
So on the last ones, you only do 43, 45, 47, 49.
Hey, what are we?
3, 45, 47, 49.
Okay, good. That's what I wrote down.
And look, it's pictures of graphs doing
Is
this.
pizza here?
That's 43, 45, 47, 49. It's this.
I'm confused with coming in the morning, so I